All right, friends and neighbors, welcome back to a CCNA video. This is Chapter 1, Video 2. So I was thinking about how in the world we were going to get through this book. Actually, there's 2 volumes, right? And there's a lot of chapters and a lot of content. So normally, I like to keep videos between 10 and 15 minutes, a particular idea or particular demo. I have done longer ones. I think we're going to have to do longer ones for this particular series because if we don't, we'll never get through it all. So I'm going to go about a half an hour max and as many as it takes to get through volume 1 and volume 2. I am not going to assume that you have any networking knowledge. The CCNA is written very introductory sort of content and then it builds on stuff. And so I'm going to do the same thing. I'm not going to skip anything. We're going to go over anything. And I will occasionally add stuff to the conversation like I'm going to do in this particular video. So we can understand things a little bit better and maybe, get a little real life look into stuff. I'm also going to assume that you're sort of reading along as you go through this. And so I'll reference the chapter a lot so we know it's not just an idea about chapter 1. It'll be, all right, right here we're talking about this particular thing. Don't forget to take your Do You Already Know This quiz. And I think I will, why not? At the conclusion of each chapter, we'll do the quiz questions at the end if there are any. And by the way, chapter 1 is a lot of background. So according to the chapter text, it's not even on the exam, but it gets us sort of our, the grounding, our feet wet into what's going on. Okay, on to the chapter. So the first section is perspective on networking. And there's a couple of ways to think about networking. On one hand, you can think about, well, how am I connecting? You could be connecting via a cable, and that could be Ethernet. Your home or your business could be connected via, well, cable in this case being coax or DSL phone line or fiber optic cable. Your physical machine, like this one here, could be wired. I could have an Ethernet cable, or I could be wireless. So I could be doing Ethernet or 802.11. We could think about network size, right? Your home network has a wireless home gateway at the edge of it, and everything is connected through there. Many small businesses, very small businesses, are hooked up in the exact same way. So that's the small office, home office kind of thing. And a lot of the same issues, a lot of the same types of equipment, we call that SOHO. The next step up is the small to medium-sized business. And the differentiation between SOHO and SMB or enterprise is usually the number of people that are employed. So if you've got 10 to 15 people, you're in that SOHO office. If you get up to about 50, that's SMB, small to medium-sized business, and then enterprise, of course, is something larger. And then the technologies and the complexity all scale up from there, right? You have to worry about a whole different set of things. The more people, the more data, the more infrastructure you have to worry about. By the way, enterprise is also sometimes called a campus area network. But no matter what we're talking about, it doesn't really matter if we're talking about 802.11 wireless for your house or 802.11 wireless for the enterprise, it's still 802.11. Now, it's more complex. I'm not going to say that. You have lots more equipment, lots more frequencies to worry about, lots more security concerns, architectures to worry about. But the technology, the underlying technology is the same. Now, another thing that's important is that a lot of our networking is invisible to the user, right? It's pervasive. It's everywhere, but it's totally invisible to the individual user. And by that, I mean that when somebody hooks up to the network, they just expect it to work. And for the most part, it does, right? They get an IP address from someplace. They're able to connect to the web via some series of connections. And it's going to be your job to make sure all of that works. In fact, it's often said that the minute the network is visible, well, there's a problem and you're going to get complaints. So this whole first section of chapters is really about basic enterprise network construction and how to configure it. Now, we started talking last time about the TCP/IP model. Now remember that a model is sort of an architecture. So networking operations, network devices, and it doesn't really matter what we're talking about, all follow a series of rules. And there's a lot of rules, and there's a lot of different operations that occur just to get a packet from one side of a network to another. Is really sort of amazing. All of these rules are in the standards and RFCs from the Internet Engineering Task Force and the Institute for Electrical and Electronic Engineers. The model itself is sort of the architectural plans for all of these devices and all of the operations. So every task, every address, every device is restricted to a layer or two of our model. Now, right above me here, I think you can see the TCP/IP model. Now, it's called the TCP/IP model because these are the protocols that we talk about most often. But we could just as easily call it the UDP/IP model. We could say TCP/IPv6, UDP/IPv6 if we wanted to, because those are both layer 3 protocols. But for the most part, we're going to call it the TCP/IP model. And we know now that this is RFC 1122. 1123 is its companion document. So this is where we can actually see the rules for all of these layers and all of the operational requirements. We also know that historically there's been a lot of models. The International Business Machines Systems Network Architecture, that was a model. AppleTalk's model, Novell NetWare, the OSI model, and of course the TCP/IP model. Early models were highly vendor specific, so vendor lock-in was a very real thing. The more we use standardized protocols, the same ones that everybody else is using, it's harder and harder for a vendor to lock us into their gear. It was extraordinarily difficult to break out of a particular vendor when everything that you're using is specific to them, and all of your applications and all of your code is specific to how they do things. So what we're going to talk about is some common terms and protocols in this introductory chapter. And in that model above, what I've added there are the applications and the protocols that you see at a particular layer. So now by this, I'm not talking about, the apps that the user interfaces with, but it's the protocols that interact with the app. So all the way up there at the application layer, you can see things like FTP and HTTP. Layer 4 is our transport layer, and we see TCP and UDP there, or the Transmission Control Protocol and the User Datagram Protocol. The IP layer, so named because of IPv4, but it's really the network layer, has, well, if we were just going to really be focused, we would say just IPv4. But of course, there's IPv6 there. That's another layer 3 main protocol. But the minute you're doing IPv4 or IPv6, you also have protocols like ICMP. Now, all of these are going to be study items later on. Down there at the lower layers, 2 and 1, we see the link layer and we see the physical layer. And the two protocols that are the ones, the big dogs today, are going to be Ethernet and 802.11. Now, historically, there's been a lot of them, but those are the two main ones. Now, what we'll also find out is that the TCP/IP model, RFC 1122, it doesn't really talk about link layer or physical layer at all. It just says, hey, if you want to know more about these, we've got a set of rules about what should happen down there, but we're not going to reinvent protocols. Go see the ones from the IEEE, Ethernet and 802.11. Okay, all the way up at the top there, we have the application layer. And as we said, these are protocols that interact with actual user applications. But are these actually the applications? Well, no, they're not. So when you have, say, an FTP client or an HTTP client, your browser, these protocols provide the services that those applications actually need. So if you're doing mail or a game, application layer protocols provide the services that you need. So for example, one requirement is that there must be a mechanism for reporting error conditions to the application. So somehow the applications has got to be able to figure out, oh, there's a problem down below. For example, I lost some data, and so I need to resend that data. So there has to be some kind of interaction with the actual user application. Now, there's going to be a lot of common terms that we have when we start talking about applications and what goes on with the application in the next layer down, that is the transport layer. So the transport layer uses port numbers, and every application is tied to a particular port number. So we're going to talk about port numbers a lot. Another thing that's common to talk about when we start talking about applications is this idea of a socket. So the source and destination port numbers, the source and destination IP addresses, those constitute the socket, those four numbers together. And so the client-server model is one that all applications observe today. So HTTP and HTTPS are two good examples of application layer protocols that are providing services to the browser above them. So I think we talked a little bit about HTTPS and last time. Now these two protocols date from 1999 and 2000, so a long, long time ago. They didn't even really exist until we had this concept of being able to see pictures in a program that's looking over the web. When I first got started networking, all that stuff was text-based. The browser that I used was called Lynx, and all that you did was you got stuff to read. So there were no pictures of cats or dogs or birds or anything. It was just text-based. Now, I think we saw last time that there's a particular way to read RFCs. I'll show you that here again in a second. But most RFCs have been updated or even obsoleted by later RFCs. So HTTP and HTTPS have changed quite a bit. You can see in these two examples, we start off with RFCs 2216 and 2818, and then both of them have been replaced by much later versions. Common ports, transport layer ports that go along with these are 80 and 443. We got from these documents, right, the message syntax, the message parsing, connection management, and related security concerns, all are services for the application that lives above it, right, the browser. So let's take another look at that RFC real quick. So here is RFC 2616. So if you wanted to, you could read the entire RFC, right? All of the rules. This one's a long one, right? So there's lots and lots of stuff. So if you were trying to understand a particular protocol or a particular idea, you would read the RFC associated with that protocol or idea. And we will take a look at these as we go along through this course. But there's a couple of other details here. We can see up here that this RFC was obsoleted by later RFCs. Right? And if we click on these, right, we can see the trail that would go on, right? So this one obsoleted the previous, and then this one was in itself, or in turn, obsoleted. We can also see the history, right, where this one came from. But then we can also see all the folks involved. And there he is right there, the man credited with being able to see pictures over the web, a browser, Tim Berners-Lee. You can see that he was one of the authors of this particular document 25 years ago. Now I've got a packet up here. We said that the application layer protocols provide services or provide information that the application above them really needs, right? The user application. And so you can see here that I've got my user agent, right? Firefox, Mozilla, and then the encoding that I'm using and so on and so forth. So that is what this particular application layer protocol is trying to provide. And here are our layers, right? Layer 2 is Ethernet, layer 3, the IP or Internet Protocol, Transmission Control Protocol, layer 4, and then HTTP. So now if we move down to transport layer basics, so this is layer 4 now, there are really two protocols. Now again, historically, there's been lots and lots of protocols that have been used at layer 4, but now that we're settling on the TCP/IP model, we are going to limit ourselves to the Transmission Control Protocol and the User Datagram Protocol. Now there's not much to UDP. It's actually a very, very simple protocol. It's used mostly for transactions and real-time streaming. But TCP has lots and lots of functions. In my classes, I like to call it the mother hen protocol because it's really trying to keep track of data. So the chapter covers some error recovery basics, sequence numbers and acknowledgement numbers, window size, sliding window, and then all kinds of stuff. All right, so I'm gonna say some things here, and then we'll look at an actual capture example. So TCP is very concerned with making sure that all of your data gets there. And so both sides in a conversation, they sync up with each other and they say, here's my sequence numbers. Here's the numbers I'm going to use to control my bytes. And I'm going to say, here's my sequence numbers, the numbers that I'm going to use to control my bytes. The two sides have acknowledgement numbers that reference the other side's sequence numbers. Now, we will talk more about this later on, so don't freak out if there's a lot to this. The other thing about the TCP conversation is that there's a flow control mechanism that says, look, you can only send me too much, or you can only send me so much data before I need time to process. And that's a window size. You can send me this much data. And every time you send me a little bit, I'm going to close my window a little bit. That's sliding window. When I get done processing it, I'll tell you, and I'll open the window back up. If we lose any of the chunks of data along the way, either side has the ability to say, hey, I lost something, here's another copy of it. Now, there's a little bit more to it than that, and we'll talk about that, but that's sort of the basic ideas. TCP, very concerned about the bytes as they go across the wire, very concerned about not overrunning the other side, and has the ability to recover lost data. So let's look at a capture example. So here is a TCP conversation starting up. So here are two nodes communicating with each other. And there's something called the handshake, SYN, SYNAC, ACK. These are TCP flags. Again, we're going to cover TCP. But let me show you an initial part of the conversation. So here's our encapsulation again, Ethernet, IP, TCP. And within TCP, we can see sequence numbers. Now we should look at the hexadecimal value down here. Okay. Now this is the beginning of the conversation, so the other side hasn't told me its sequence numbers yet. So now, when I go to the next packet, I can see that I have sequence numbers and the other side had its sequence numbers, which I will refer to as acknowledgement numbers. So again, we're going to talk more about this, but the two sides have their own sequence numbers and reference each other by their acknowledgement numbers. Also in this is a window size. So the window size tells me how much data I'm willing to accept. And then we have some additional options and things like that. But there's an actual capture that shows you the values that we're talking about here. So sequence numbers and acknowledgement numbers and window sizes. Now again, don't panic if this is brand new to you. We're just introducing the idea. I want to hit your brain with it a couple of times, and that way we'll make sure that it sticks in there. Now, the layers are not in isolation from each other. They have to be able to interact. So when I am forwarding traffic, right, I have an email message and I put it in an email client, and that goes down into an email protocol, and then I give it to TCP. Clearly, there's an interaction there. And then TCP says, hey, IP layer, network layer, can you send this across the network for me? So the TCP layer is out at that point. It's done, but it talked to the application layer and it talked to the routing layer below me. So there's what we call interlayer or adjacent layer interactions. Happens all the time. This is a process called encapsulation. But two computers don't think about that. Two computers have applications that are talking to each other, right? I emailed you something. Did you get it? Yep, here I go. And so those are what we call communicating at the same layer. So that's same layer interaction. So if we're talking between two routers, they're talking at layer 3. Two switches, we'll talk at layer 2. Applications will talk at layer 4 and layer 5 together. So we have a couple of ways to think about how we use this model and how communication occurs. Well, if we move down to layer 3, we can call this the IP layer or the network layer. There are two basic functions, and this is a quote right out of the RFC. There are two main functions. Choose the next hop gateway or a host for outgoing datagrams. And the other thing is to reassemble IP datagrams. So I send a big file your way. It's too big to go over the network in one piece. And so we have to have a way to break it up, send it across the network, and put that back together. That's a really basic function. Imagine that you were sending a video file. Video files can be very, very large, and we can't send it all at one go. But the next hop gateway, that's really, really interesting. That's actually routing. So somehow we have to figure out, if I want to send something from here to Australia, I have to figure out who I'm going to send this to so that they can help me get this to Australia. And it turns out there are a whole bunch of hops along the way, or a whole bunch of router interfaces that we use to go from one place to another. So those are our two basic functions. There are others. There are lots of things that the IP layer or the network layer handles for us, but those are the two main ones. Now routing, again, is all about finding that next hop. And we can do that in a particular way. We can say, here's what it is. I'm going to statically configure this so that you know who it is. But routers can also discover each other through the use of dynamic routing protocols. Now the chapter also talks about addressing bases. Let's do a couple of examples here in a second, but the basic IP address scheme, right, or the structure, is called the dotted quad notation. So I've got this example here, 3.4.5.6. The book has a couple of other examples. So that format is dotted quad. Each one of those is a byte. So a dotted quad notation, an IP address is actually 4 bytes. Now we can think of IP addresses in a couple of ways. You can think about them as classes. You can think about it classless. We can say there are public IP addresses, there are private IP addresses, there are IPv4 addresses, IPv6 addresses. We're going to get through all of that. But for right now, we just want to try and remember that the IP address basic format is this dotted quad 4-byte notation. Okay, let's do a live capture. So here I am back in Wireshark, and I'm wireless right now, so I'm going to choose my wireless adapter. Now, I'm not going to do anything. I'm just going to let this go, and I'll just pull it down here so you can see, yep, there's lots of traffic going on here. And, you know, it's not terribly busy from this machine because I'm not doing anything. But if you take a look at these two columns, we can see that there is an awful lot of IP addresses here. Now, it'll be our goal to understand a lot about those IP addresses, where they're going, what they're for, what the different numbers mean, and that there are a whole bunch of conversations or flows in here. Now, if I just stop this capture here, and I take a look at one address maybe. Here I've got this address here, the 10net, but maybe let's see if we can find, let's take a look at some statistics, and then we'll do conversations. Now this, by the way, is Wireshark. If you've never used Wireshark, it's a free download. You can take a look at, you can actually just search for Wireshark and do a free download and do your own captures. And I'm going to take a look at a couple of IP addresses here. And we'll see, I may have to open up a browser to get one, but that looks like a public address right there. 34.110.138.217. Now, these are IP addresses, and I'm having a conversation with them, and my machine has to be able to get to all of the destinations that I might want to converse with. But what about that routing thing? What about that routing thing? So let's do a fun little tool. So I am going to trace route to that particular destination. So trace route is a tool that shows me the hops along the way. Later on, we'll talk about exactly how this works and what is it doing, but I'm just going to do trace RT. We'll do 34, what is it, 110, 138, right? The dotted quad notation. And I lost it. There it is, 217. Okay. Now what this is going to do is go out and send messages out and wait for responses back. And what I'm getting here are the routers or hops that I passed through on the way to the destination. All of these are routers or interfaces along the way. So there we go. And eventually it'll wind up at the destination. And I'll have not only an idea of how many routers I passed through, but how long it took to do that. There we go. So the trace is complete. There we see the address. And this is the collection of routers or the collection of router interfaces or hops that I went through to get to that particular destination. Now, when we start talking about all of the rules or the things that each layer is responsible for, right, we list a couple of them, but each layer is responsible for a whole bunch of things. And we can take a look at some examples in RFC 1122. So here we are in the TCPIP model RFC, right? Requirements for internet hosts. And if I go and I just select a particular layer, right? And I say, well, let's go to the link layer. And we'll find out that each layer is going to have a collection of things that it has to do. And there's a table that says that for every host that's connected to the internet, there's a list of things that it must do, that it should do, and so on and so forth. It should not do this. It must not do this. And so we can see that this collection of ideas or this collection of responsibilities is at, in this case, layer 2. And so every one of our layers has this list of jobs or responsibilities, things that it should do, should not, must do, must not, for every single host. Now, the book chapter gives a post office example. So there's a lot of similarities between post offices and the Internet Protocol or our messaging. I also like to use traffic as an example. But in this case, we'll do the post office example from the book, right? So every letter that you send has the sender's address, the return address, and then the recipient's address. IP packets have the same thing. The postal system has a routing function, right? You know that you're going to send it to the post office. The post office is going to put a stamp on it that says, I handle this, and send it off to the destination or maybe to the next hop. This is very similar to the basic routing function that we have, and the fact that postal hubs will send traffic or mail to the next post office hub is very, very similar to routers sending things to other routers. So when you look at a diagram like the one here on this slide, we can see that there are lots and lots of sites associated with the internet. I mean, if you think about the number of companies, organizations, houses that are on the internet, it is truly a mind-boggling number. And somehow, your machine is able to send traffic to any public address that's out there. And the internet is going to handle all of this for you. There's a phenomenal number of transactions that have to happen for that functionality to actually work. Imagine that I was going from all the way on the left to all the way on the right, and it doesn't really matter which site. Which pathway would I take through the cloud? Well, there might be multiple ways to go. Which one is best? Is there only one path that I should take? How would I discover the pathway to begin with? All of these are built in, and these are some of the things that we really, really want to understand as we get through this particular certification. Let's take a last look at our capture here and what the IP header looks like. Since we were just talking about routing and the post office, we take a look here in every IP packet, right? So if we'll do the encapsulation, there's the IP packet. Every IP packet has a source and destination IP address. And as we saw from the trace route, I'm sending this through a series of routers. So this behavior is very much like the forwarding of mail. Well, we've reached the half-hour mark. This has been CCNA Chapter 1, Video 2. And in this one, we covered TCP model basic, right? Application, transport, and network layers. We did an HTTP application example, and we looked at a bunch of captures to help us formulate some of our ideas. Next up, we'll do Chapter 1, Part 2. That'll be Video 3 in Chapter 1, and I think we'll conclude at that point. All right, like and subscribe for the exciting end to Chapter 1, our Introduction to Networking. And no matter how you're feeling at this point, we're going to make sure those packets get to those destinations. And remember, it's networking. You can do this.